Yeah, hi. So in this problem, our task is to find the longest valid obstacle course at each position. And this is today's daily challenge. It is of 7th May. And yeah, our task is that we have a vector, a vector of obstacles where each cell represents the height of an obstacle. Now let's understand the problem. I'll not be reading the problem out loud. I'll explain the problem directly. So here in the problem statement, we have to return the answer vector in which we have to find out the obstacle course for each point. Let's say for this, the obstacle point will be the longest increasing subsequence, including this 3. And in the longest increasing subsequence, there are duplicates possible. So when we have to include this 3, then the answer will be 1, 2, 3, that is 3. That's why here it is 3. Now let's understand for this test case. For 3, the answer will be 1 because there are no elements prior to this element 3. For this one, the answer will be 1 because there are no smaller elements prior to this 1. That's why 1. For this 5, the answer will be 2 because if we take it either way, 3, comma 5 or 1, comma 5, the answer will be 2. For the 6, the answer will be 3. 3, 1, 5, 6 can be one answer, 1, 5, 6 can be another answer, but the length is 3. That's why answer is 3. For 4, the answer is 3, comma 4, that is 2. For 2, the answer will be 1, comma 2. Okay. So now let's understand the logic. See, we can solve it in quadratic time complexity as well, like we used to solve longest increasing subsequence problem, where we will be at, let's say, index, the last index. So we will go to all the values prior to this value and check if it is smaller than, and then we will include that the answer of that particular value only. Okay, but because the constraints are high, that is n is 10 to the power 5, so we cannot solve it using a quadratic solution. Okay, because the uh, time limit exceeded will be the outcome for the solution. Now let's analyze how we will use binary search to solve this problem. And if you have solved the longest increasing subsequence problem with the help of binary search, then it is quite similar problem. Okay, so let's understand what we will do in this problem. We will have two vectors, current and answer here. Okay, we have current and answer. And initially what we will do is, because for index 1, sorry, index 0, the answer will be 1 no matter what. So that's why we will insert 1 here, and in current we will insert 3 here. Okay, now we are at index 1. Now what I'll do, I'll apply binary search in current for the first element greater than obstacles of I. Okay, so this is what we will be doing. Okay, so when we are at this one, we will apply binary search for the first element greater than obstacle I. So the answer will be 3 only. So what we will do is we will overwrite 1 in place of 3. Okay, now what is the index at which this 1 is placed now? So the index is 0. So we will be pushing 0 plus 1 in our answer because the count is equal to index plus 1. Okay, now we are at this 5. We will apply binary search in this current for the first element greater than obstacle I. So there are no element which are greater than 5. So that's why what we will do is we will simply push this 5 in our current vector. Okay, now what is the index of this 5? The index of this 5 is 1. So we will push 1 plus 1, 2 here. Now we are at the 6. For the first element which is greater than this obstacle I, there are no element greater than obstacle I, that is 6. That's why we will be pushing 6 here. And similarly, we will be writing 3 here, that is index plus 1, index is 2. So here we are pushing 3. Now, again, we will move on to this 4. We will again apply binary search. For binary search, the first element that is greater than this 4 is 5. Okay, so we will overwrite 4 in place of 5, and we will push 2 here because the index is 1 and 1 plus 1 is 2. Now we will come on to this 2. We will apply binary search again. The first element which is greater than this 2, it is 4. We will overwrite 2 here, and we will again write 2 as the answer. Okay, so let's check whether this is the correct answer or not. So yeah, 1, 1, 2, 3, 2, 2 is the correct answer. So yeah, now if you have doubt that why we are overwriting, pushing is quite obvious, but why are we overwriting? Because see, the next element after this I will either be greater than or less than the particular value. Okay, so if it is greater than, then there is no point. Then we can simply overwrite, because if the element is greater than 5, then it will also be greater than 1, right? And if it is smaller than 5, then we will never be including 5 in our answer, because we have to find out equal or smaller than, right? So that's why we can overwrite. Now let's write out the code. So yeah, we need two vectors. One vector is current, and in current we want to push obstacles of 0, and then we want answer vector as well. And inside this answer vector, we have to push 1. Now we will write for loop. Inside this for loop, what we will be doing is we will be writing the solution, the binary search solution. So int L is equal to 0, H is equal to current dot size, because we are applying binary searching, current vector, and let's write end here. Now while L is less than equal to H, int mid is equal to L plus H minus L by 2. So if current of M is greater than obstacles of I, then what we will do is we will write int is equal to M and H is equal to M minus 1. Now why H is equal to M minus 1? Because we want the first element which is greater than this obstacle of I, right? So let's say हम लोग को मिलता है element जो कि let's say index at 10, which is greater than obstacles of I, but there exists an element which is at index 6, let's say, which is greater than obstacle of I. So we want that particular sixth index element, not the 10th element, 10th index element, right? So that's why we are writing H is equal to M minus 1, and yeah, else L is equal to M plus 1. And when we come out of this while loop now, so if int is equal to minus 1, so when int is equal to minus 1, that means we didn't find the answer in our search space. So that means we have to push back in the current. We are pushing back in the current. What we are pushing? We are pushing obstacles of I, and answer dot pushback current dot size, basically. Else what we are doing? We are overwriting current of end is equal to obstacles of I, and answer dot pushback end plus 1. Okay, and at the end we will be returning an answer. Let's run our solution. Okay, so my bad, I have to write int n is equal to obstacles dot size. Okay, let's see what the problem is. Expected is 1, 2, 3, 3, and my answer is 1, 2, 3, 4, 4. Why? Okay, yeah, my bad. I have to write 1 here because for the zeroth index we already took care of it, right? So that's why we have to traverse from 1 to n minus 1. Yeah, now our sample cases are working fine. Let's submit a solution. Yeah, our solution is accepted. So basically, we solved this problem using the concept of longest increasing subsequence only. And it is quite obvious because we wrote the binary search solution, and it is quite obvious. And yeah, if you have any doubt, then do write it in the comment section, and I'll surely try to cover it in the next video, and I'll explain this solution again if you have any problem. Okay, and yeah, that's it from my end. And do like the video, comment, do write the comment if you have any problem or if you find this video helpful, and do subscribe the channel. And yeah, so we'll meet in the next video. Bye then.